Okay, before we start with some questions or some exercises regarding on this topic, I open for Q&A. If you have any question that you want to ask, then you can ask me now. Ada soalan nak tanya? Any question? Tak ada soalan? Kita tengok lagi video. No question. Okay, regarding on the question yang soalan kawan awak tanya semalam. Okay, I think this slide. Okay, before we start, let me explain again about the solution steps on the primary and secondary. Alright, so as I mentioned in the video, for radial and V engine, there are 4 types of forces that we need to investigate on. What is that? First one is primary direct force, or we call as FPD. Okay, FPD, which is direction is always outwards of the crankshaft, right? So let's say the direction of FPD is basically depends on how many firing orders we have. All right, let's say for example, if we have a firing order, sekejap saya buat. Okay, for example, if we need to find if we have firing order, for example 1 3 4 2, okay, and then from here we need to find what, to find a primary direct force, okay, based on the number of stroke and also how many cylinders we have, isn't it? How many cylinders? If for example, if we have firing order 1 3 4 2, meaning to say that we have 4 number of cylinders. Alright, so how to find, for example, if we have 4-stroke engine, so meaning to say that one complete revolution must be 7 to 0, isn't it? Because 4-stroke engine, to complete one cycle should be to apa kita panggil, kita mesti ada 2 putaran until 7 to 0. So how to find the number of n? So n is basically depends on the number of cylinders and also number of stroke. Okay, for example, if we have a 4 cylinder with 4 stroke, so meaning to say that our theta for each crank must be 720 divided by 4, okay, which is must be 180 degree. 180 degrees. So in order to find force primary direct force, so if we draw our crank, so each of primary force should be 180. So for example, For example, if of the forces for each cylinder occurs on the first, let's say this is 0, we start with 0, okay, and then we have 90 degree, we have 180, and this is 270. Okay, so in order to find the primary direct force FPD, it must be act outwards of the crankshaft. So biasanya kalau untuk primary, biasanya dia akan share same radial or same line of crankshaft. So basically kita akan ada 4 lah dekat atas ni, 1, 2, 3, 4 FPD. So ni saya bagi contoh, nanti kita tengok example, kita tengok exercise lagi kejap lagi. So in order to find primary reverse force, it should be depends on the cylinder line. So for example, if we have cylinder line of crank, for example this cylinder line of 1, this is cylinder line of 2, 3, 4. Okay, so untuk dapatkan FPD for cylinder line number 1 should be same. So meaning to say that for force, for primary reverse force must be upward as well untuk cylinder number 1. For cylinder number 2, they should be reverse. So from number 1 to cylinder number 2 is here. So this is theta, isn't it? Theta. So untuk dapatkan dia punya reverse, should be, dia must be reverse lah, reverse daripada line. So maksudnya untuk nombor 2 dia must be downward. This is untuk F reverse force. Alright, untuk nombor 2. Untuk nombor 3 pula, nombor 3 dia punya cylinder line pun dekat sini kan, so dia akan sama lah. So bila kita buat untuk force untuk primary reverse force, dia should be dekat atas ni, dia must be 1, 3, kat bawah mesti 2, 4. Macam itulah lebih kurang. Okay, ni untuk primary direct force. This is primary direct force, and this one primary reverse force. Okay, FPR dan FPD itu adalah yang primary. Untuk secondary pula, okay, nombor 4 ni, if the FPD makes an angle theta measured from cylinder line, so the FSD makes an angle to theta. Dan kita tahu theta dia mesti, untuk secondary dia mesti to theta. To theta maksudnya this is theta. Okay, this is theta. Untuk dapatkan 2 theta, dia mesti macam mana? Dia mesti kena consider daripada makes an angle theta measured from the cylinder line. Okay, measured from the cylinder line. So where's our cylinder line for number 2? This is our cylinder line for number 2. From, they must be refer to number 2. So maksudnya untuk dapatkan secondary direct force ni, kita kena refer force FPD untuk setiap cylinder tu dekat mana. So kita tahu untuk setiap cylinder must be upward. So from cylinder number 2 theta, jadi kalau untuk dapatkan 2 theta macam mana? 2 theta maksudnya theta dekat sini, 2 theta dekat sini lah. Betul? Dekat situ. So maksudnya untuk for secondary direct force, okay, untuk nombor berapa? Nombor 2 maksudnya dekat sini. So ini nombor 2. Okay. And then nombor 3 pula. Nombor 3 dekat sini kan. Sini ke sini. And then untuk dapatkan 2 theta, dia mesti direction balik. So nombor 3 dia must be downward. Number 3. For number 4, sini ke sini theta, untuk dapatkan 2 theta dia mesti sini. So number 4 must be dekat sini lah. Kat sini 1. So kalau kita letak dekat sini, yang ni dah balance, yang ni pun dah balance. Sama. Itu contoh lah. Okey, kita tengok soalan. we look at the first question about this topic. Okay, look at this question. A 4-cylinder engine is running at 2400, okay, 2400 with crank radius R equals to 120 millimeter and connecting rod length R equals to 240 millimeter. The reciprocating mass corresponding to each cylinder is 1.8 kilogram. Okay, for this question, what types of reciprocating balancing here? Inline, radius of V engine. We have three types of reciprocating balancing. Yang mana satu this one? Inline. Betul lah inline kan? Because dia dah beritahu kat sini dah. So, a 4-stroke inline engine as shown in figure question 2A with firing order 1, 3, 4, 2 and the cylinder are spaced 200 mm apart. Investigate the degree of freedom. Maksudnya dia nak dapatkan dia punya balancing force and moment. Untuk inline engine kita ada 4 types of parameters that we need to consider, kan? First is about primary force, okay, and then we have secondary force. We also need to consider primary moment or couple, and last one we need to find secondary couple for inline. Okay, so first step is we need to find n, isn't it? We need to find how many n's we have. So how to find n? Remember the formula? What is our formula in order to find n? N equals to L over R, isn't it? So what is our L? L is 2 for mana L? Connecting rod length. This is L sebenarnya ni. L. So L is 240 divided by radius is 120, which is N is 2. N is 2. So how to find theta for each cylinder? Theta must be kita tengok how many stroke we have. 4 stroke. So 4 stroke means to say that there must be 720 divided by how many cylinder? We have 4 cylinder. So theta for each cylinder must be 180 degree. Okay, so that is our N and that is our theta. Okay, so dia beritahu firing order kita adalah 1342. 1342. Okay, so first step is you need to investigate the reference plane. Where is that? There must be symmetry or in middle of the plane. So there must be kat sini lah. Okay, this is our reference. Okay, reference. So we assume that positive is to the right and negative to the left. Negative to the left. Okay, 1342. So first is you need to tabulate your table. Why? Because this one is basically we need to find the value of couple or moment. So just construct your table first. Okay, construct your table. We have plane MRD theta to theta. So this is plane. And we have M, we have R, MRD theta and 2 theta. First is based on firing order 1. Okay, 1. We also have next is 3. We have 4. And last one we have 2. Last one we have 2. So dia beritahu kat sini dia punya mass untuk setiap silinder sama 1.8. 1.8, 1.8, same. R pun sama 0.120. So convert into meter, so we have 0.12 sama. And what is our M? MR 1.8 darab 0.12 should be 0.216, isn't it? So sama juga. Okay, yang membezakannya adalah D. So D, we taking our reference at the middle of the plane. So we need to say that for plane number 1, our D must be negative 0.3. Okay, so we have for number 3 must be 0.1. Okay, and we also number 4 should be 0.3, and last one we have negative 0.1. Okay, so M is negative 0.3 darab dengan 0.216 should be negative 0.0648. Negative 0.0648. So untuk yang ni kita ada 0.0216. Okay, we also have this one should be 0.0648. And last one we have negative 0.0216. So how about theta? Theta for plane number 1, 1342. So 1. So should be start with 0 lah. Direction dia ke kanan. Okay, and then we have 180. 180 maksudnya if look at the dia punya angle reference theta dia bagi dekat situ, maksudnya untuk firing order for number 1 should be dekat sini lah 1, and then each of, kita tahu setiap silinder tu dia akan beza 180. So next firing order dia mesti ke sini lah, sebab based on reference dia bagi 0, 90, 180. Jadi 1, 3 dekat sini, and then number 4 dekat mana? Number 4 must be back dekat sini, and last one we have 2 ataupun dekat sini 2. So 1, 3, 1, 3, 4, 2. Okay, setiapnya adalah 180 degree. Okay, so that is our position of cylinder. Alright, so next is maksudnya for number 3 dia punya kedudukan number 3 should be 180. And then number 4, kalau kita nak buat in terms of kedudukan rotation yang dekat sini, maksudnya kan dia punya one complete cycle must be 720. So maksudnya dia akan start with 1 sampai 3180, dia akan pergi ke 4 which is 360, and last one 4 until number 2, last dengan nombor 2. Nombor 2 maksudnya 540. Okay, so how about 2 theta, just darab je lah 360, okay, 720 and 1080. So this is our table lah. Kalau tak nak buat table tak apa, saya buat table untuk just for reference, nampak lah sebenarnya. Okay, so next is we need to find our primary force, isn't it? Primary force, we need to find our primary force. First is we need to ensure that our primary force is balanced or not. Okay, primary force. So bila kita lukis kita punya diagram, so kedudukan primary force untuk nombor 1, nombor 2, 3, 4 dia mesti kat mana? Kat sini lah. So yang ni 1, 4, yang ni 2, 3. So kalau kita lihat sini, for primary force already balanced or not? Ada tak unbalanced force dekat primary force? Is there any unbalanced force? balance lah sebab dia sama, kanan kiri sama, same. So there is no, kena beritahu lah balance ataupun beritahu no unbalanced primary force. Alright, kena beritahu. So this is our conclusion for primary force. Okay, number 2. Apa rumus? Kita punya rumus untuk primary force. F sama dengan mr omega square, isn't it? Mr omega square untuk primary FP. Kalau untuk F secondary should be mr omega square over n. Okay, over n. Okay, next is we need to find our primary couple. Primary couple balance ke tak? So for primary couple or moment, okay, our MP should be MRD, isn't it? MRD omega square. MRD omega square. So untuk dapatkan primary couple, kat mana kedudukan dia? Where's our position? Okay, look at from the table. So this is our MRD. So position of MRD omega squared negative 0.0648 for number 1. So number 1 kat sini. So we have negative F1 M1 should be negative 0.0648. So negative 0.0648, ataupun tak nak buat dalam terms of number pun boleh juga, just buat negative MRD. Tak boleh juga, kena tahu dia punya nilai, betul-betul kena tahu nilai. So negative 648 omega squared. So this is our number 1. So how about number 4 ataupun number 2? Number 4 lah, kita buat number 4 dulu. Number 4 ini kan 0.0648. So number 4 is sama M4 0.0648 omega squared. For number 3, what is our number 3? 0.216 omega squared. And last one we have M2 is negative 0.216 omega squared. So kalau kita dekat sini, for primary couple, is there the balance ke tak? The couple is already balanced or we have unbalanced primary couple kat sini? Okay, balance lagi lah sebab nilai dia sama. If we look at this one, if we taking summation of, or we resolve summation of mx equals to 0, then we have negative 0.648 plus 0.0648 minus 0.216 minus negative 0.216, and then at the end our result must be 0. So bila resultant is 0, maksudnya dia punya primary couple is balanced. So balance or no unbalanced primary couple. Okay, senang je topik ni. Cuma kena tahu dia punya direction tu yang penting. Okay, next adalah kita nak consider secondary force pula. Secondary force. So this is number 1, number 2, and number 3, secondary force. Okay, secondary force pula. Kita tahu secondary force kita kena consider dia punya theta should be double. Okay, must be double. So bila kita buat kita punya diagram, okay, Dia must refer to primary force. Nampak? 1, 4, 2, 3 situ. So, number 1. Number 1 still sama lah. Betul? Sama. And then number 3. Next is number 3. Number 3. From 3 should be kat mana kedudukan number 3? So, since our theta is 180, maksudnya dia must be 360 to theta. So, 360 maksudnya kedudukan mesti dekat sini lah, number 3. Okay. And then, number 4, we have 720. 720. So, we need to say that we have same sini. Number 4. And the last one, we have number 2, which is 1080. 1080. Dekat mana? Sama kan? Must be dekat sini juga. 1080. Okay, so kedudukan dia sama. 1, 3, 4 tu dekat situ. Okay. So, 1, 3, 4, 2 dekat situ. Jadi, kedudukan dia 1, 3, 4, 2 pada position yang sama. Same position, meaning to say this one we call as, we have unbalanced secondary force. Okay, betul. Because dia tak balance, sebab dia hanya bergantung kepada first place only, dekat sini saja. So there is no secondary force dekat other place. Alright, so this one we call as unbalanced secondary force. Then we need to find how many forces that we have for secondary force. So how to find it? So since we know that our Fs should be m r omega square over n. Since we have 4, so Fs total should be times with 4 lah. So Fs total must be, what is our mr? Mr is same, 0.216. 0.216 darab dengan omega. Omega is berapa omega? 2400. 2400 bahagi n lah. N kita 2. N kita 2. 2400 darab dengan 2 pi over 60 bahagi dengan n kita 2 kan. So darab dengan 4. Okay. So what is our FST? Secondary total. Cuba kira berapa? Berapa jawapan dia? Ke saya salah? Sekejap. Oh, kena kuasa 2. MR omega square. Sorry. Omega. MR omega square. So 2400 darab 2 pi. Sorry. 2400 darab 2 pi. Bagi 60 square. Darab 4 darab 0.216. Bahagi 2. So 27K, isn't it? So 27287 Newton. So that is our FST. Okay? FST. Any question? Nak tanya? Any question? Tak ada semua faham Okay, last one, we need to find M secondary couple. Tak payah darab untuk ni. Darab apa? Tak payah darab D. Force dia tak ada D. D hanya untuk couple. Okay? D untuk couple. Yang ni kita kena consider. Untuk nombor 4 ni. Okay? Secondary couple. Or moment. Bunyi ayam siapa tu? Okay, untuk couple, kat mana kedudukan kita? Where's our position of couple? Kita tengok dia punya primary couple. So, untuk secondary couple, same. Kita akan tengok dia punya kedudukan. Dia mesti 2 theta kan? Daripada secondary couple, secondary couple dekat sini 1, 4, 3, 2, maksudnya dia punya M pun all M dia should be kat sini lah. So M1, M4, M3, M2 sama kan? Kedudukan mesti sama. Same. So bila kita dekat situ, untuk secondary couple, dia already balance or not? For secondary couple, dah balance ke tak? No. Are you sure? Untuk secondary couple, balance ke tak? No, tak balance. Balance. Okay, balance. Kenapa balance? Sebab kedudukan nilai yang kita ada, tengoklah dekat nilai yang setiap plane ni. We have negative. So, bila kita buat M total, okay, M secondary total, kita akan dapat negative 0.0648, okay, 0.0648 omega squared, okay, plus M4. M4 kita berapa? Sorry, M4, M3. 0.216 kan? 0.216 omega squared. And then, we have M4 0.0648 plus 0.0648 omega squared. And last one minus 0.216 omega squared. Okay, omega squared sebenarnya dia bahagi dengan N ni. Per N samalah. So, MST dia must be 0. Betul? 0. Omega square over N. So, MS total, rumus dia MRD omega square over N. Sorry. So, maksudnya over N lah. Per N. So, at the end, result dia must be same. 0. So, kalau 0 maksudnya, this one is balanced lah. So, no unbalanced secondary for secondary couple or moment. Okay, faham? So, macam itulah untuk moment dengan force for inline. So, ingat yang inline punya, you need to consider primary force, primary couple, secondary force, and secondary couple for inline. Okay, any question? Ada soalan nak tanya? Tak ada. Okay. So that is about inline engine. Okay, kita tengok contoh yang berkaitan dengan radial engine pula. Radial engine. Okay, so radial engine with a common crank and cylinder arrangement as shown in figure question 2b. Okay, calculate the unbalanced for primary and secondary force. Okay, so untuk radial engine, how many uh, forces we need to find? First is we need to find force primary direct FPD, right? And then number 2 we need to find force primary reverse. Okay, number 3 force secondary direct, and number 4 we need to find force secondary reverse. Okay, so sekarang ni they share same parameters atau same condition with this one. So sama juga, we need to find the position. First is we look at the position of cylinder. Number 1, this is number 1, number 3 same, 2 and 4 same. So maksudnya bila kita lukis untuk primary force, primary direct, alright. Number 1 is primary direct. So what is our position of primary direct? Okay, position of primary direct dia bergantung kepada crankshaft yang sama dekat atas. Kedudukan crankshaft is upward. So maksudnya semua number 1, 2, 3, 4 share same crankshaft. So 1, 2, 3, 4 share same crankshaft. Alright, 1, 2, 3, 4. So balance ke tak? Tak balance lah. Right, sebab saya share same crank. So tak balance. So it is unbalanced. So therefore it is unbalanced. Okay. So how to find unbalanced force? So we have a rumus, we have a formula. FPD equals to, berapa formula dia ingat kita? FPD N over 2 MR omega squared cos berapa? Cos theta, isn't it? Ataupun MR omega squared lah. So nilai N dia berapa? N 4 kan? Number of cylinder is 4. So 4 divided by 2. M is 1.8. R is 0.12. And omega is 2400 times 2 pi over 60 squared. So our FPD equals to 27,287.48 Newton. Okay, Newton. Okay. And to number of cylinder. Number of cylinder. We have number of cylinder 4. So 4. Rumus dia. Sekejap saya tengok balik rumus dia. Mana rumus dia? Betul lah. Sebab kita ada 4 kan. We have 4. Maksudnya kita darab dengan 4 lah. So asalnya untuk satu silinder Rumus dia macam ni. FPD M over 2R omega square. So, since kita ada 4, so darab dengan 4 lah. Okay, 4 lah. So, 4M over 2R omega square. Okay. And then, untuk number 2, boleh jadi ke mass atau radius for each cylinder line. Biasanya dia sama. Dia tak akan bagi nilai yang tak sama, mass dengan radius. Okay. Untuk number 2, we need to find primary reverse current, isn't it? Primary reverse current. Primary reverse current. So, how to find primary reverse current? Okay. This is cylinder. Can tengok dia punya cylinder. Kena buat dulu cylinder. So, this is cylinder number 1, cylinder number 2, number 3 and number 4. So, how to decide our primary reverse for each cylinder? First is we must look at the position of primary direct. So, semua position of primary direct dekat atas. So, untuk tentukan primary reverse should be macam mana? Dia must be, remember our step ataupun kita punya rules dekat sini. Where is it? This one, number 2. Primary reverse force, the mirror image of FPD. FPD daripada atas lah, number 2, about the cylinder line. Okay. FPD number 1 dekat mana? What is our FPD number 1? FPD number 1 is upward. So, same lah. Should be upward. So, this is FPD 1. Sorry, primary reverse, FPR 1 kat situ. And then, how about FPR number 2? Where is it? Should be mirror from FPD number 2. FPD number 2 is upward. So, this is FPD. FPD. Sama. Same. So, FPD number 2 sama kita dekat atas. Jadi, dia must be mirror. Mirror from cylinder line number 2. So, should be downward, isn't it? So, this is FPD2. Okay. And then, for number 3. Number 3 is mirror from cylinder line number 3 from FPD number 3. FPD number 3 is upward. So, mirror from cylinder number 3. So, direction is same upward lah. FPR number 3. And last one, FPR number 4. Macam mana nak tentukan? Should be mirror from cylinder line number 4 to the FPD number 4. So, should be downward. So, this is FPR. Sorry, this is PR. FPR number 4. So, 1, 3, 2, 4. Dua-dua atas, dua bawah. Maksudnya dekat sini we consider as balance lah. It is balance. Okay. It is balance. FPR equals to 0. And so, in order to find total FP, total primary berapa? So, total primary should be FP. Kita ada FPD plus with FPR, isn't it? So, total FP hanya ada FPD saja. So, 27.3 kilonewton. Okay. Yang tak balance hanya pada primary direct. So, primary reverse is balanced. So, we just only have total FP is 27.3. So, how about secondary? Number 3. Settle yang primary. Untuk secondary pula, sama, lukis. Where's our position of secondary? Okay, remember, tengok balik dia punya rules. Nak tentukan number 3, secondary direct force FSD, if the FPD makes an angle theta measured from cylinder line, the FSD makes an angle to theta. So dekat mana dia buat, dia bagi to theta? So kita tengok, dia must be to theta, so dia must refer to FPD, isn't it? F primary direct. Kat mana F primary direct? Dekat sini. Semua kat atas. So dia mesti to theta from cylinder line. So number 1 of course kat atas lah. Same. So F secondary direct 1 kat atas. Okay, and then number 2. Number 2 dekat mana? Should be, where is it? Where is our to theta? So if number 2, dia must be from cylinder line. Theta dekat sini. So to theta nya must be this way, isn't it? So our number 2 must be here. So F SD number 2. Okay, clear? Number 2 dekat situ. And how about number 3? Must be to theta from cylinder line to FPD number 3. Dekat mana? Where is it? Number 3 kat mana? Same, kat bawah lah. So because from here we have theta here, so to theta must be dekat sini. So direction of FSD number 3 is downward. And last one, we have theta for number 4 is here. So to theta must be here. So direction of FSD number 4 must be to the right. So this one consider balance, isn't it? Balance. So FSD, total FSD equals to 0. Okay, it is balanced. And last one, secondary reverse. Last one we have secondary reverse. Okay, macam mana nak tentukan secondary reverse? So ni crank number 1, number 2, number 3, number 4. Dia must be mirror. Alright, mirror from secondary direct. Okay, to the cylinder. So kat mana kita pada secondary direct number 1? Dekat atas. Mirror to number 1 should be upward jugalah. So FSR number 1 upward. Okay, mirror from secondary number 2 to the cylinder line. Sini ke sini kan? Maksudnya mirrornya must be to the right. Must be to the right. To the right or to the left? Secondary reverse. To the right. FSD kita bahagian kiri. And then dia punya sini line dia kat mana? Mirror maksudnya sama lah kan? Dia tak ada mirror, tak ada dia punya pantulan daripada sini line. Same sebab dia punya line 4 dengan 2 sama. Bila sama, bila dekat sini maksudnya akan samalah. Dekat sini jugalah. FSR number 2, isn't it? Dia pantulan daripada silinder. Bukannya daripada nombor 2 ni. Pantulan daripada cylinder line number 2. This is cylinder line number 2. Nombor 2 dan nombor 4 share same line. Okay. So number 2 dekat kiri lah. And then number 3. Where is it? Number 3 pun sama. Downward. Pantulan dia tak ada pantulan. There are no mirror. Alright. So this is FSR number 3. And number 4 is here. So FSR number 4. Okay. FSR number 4. So this is consider balance juga kan? It is balance. Balance. Okay, so bila balance maksudnya summation of Fs equals to ST plus FSR. So this is 0 plus 0 equals to 0. So the only unbalance for force only occurs on the primary force, which is 27.3 kilonewton, and for unbalanced for secondary force is 0. Okay, so therefore untuk summarizekan dia punya dia punya degree of balance, maksudnya therefore unbalanced for primary force equals to 27.3 kilonewton, and for unbalanced for secondary force equals to 0 Newton. So this is our answer lah. Okay, clear? Any question nak tanya? Macam mana kita nak tentukan signal line? Signal line apa? Signal line kita dekat mana? Kita nak tentukan signal line dekat mana? Tengok dekat gambar Rajah dia bagi tu. Our signal line number 1 kat atas ni kan, straight, satu sampai bawah. Untuk nombor 2, dia share same line dengan nombor 4, 1, 3 yang sama. Tu je lah nak tentukan, tak perlu nak tentukan, dia akan bagi biasanya signal line. Yang perlu kita tentukan adalah dia punya secondary force dan juga primary force. Dekat mana kita nak tentukan? Macam mana kita nak tentukan? Based on rules yang dia bagi tahu dekat sini. This one. Okay, based on rule this for this one. Okay. Clear? Okay, kita tengok sempat ada satu soalan. Okay, this one. Figure question 2A shows a 4-stroke 6-cylinder inline engine. Okay. 4-stroke 6-cylinder inline engine. Determine firing order. Okay, macam mana nak tentukan firing order ni? How to determine our firing order? That will balance the engine. Okay, dia tak bagi firing order, tapi kita kena tentukan kita punya firing order. Macam mana nak balancekan kita punya firing order ni? Nak tentukan. Siapa tahu? Sama ada 1, 2, 3, 4, 5, 6 ke? 1, 4, 2, 3, 5, 6 ke? 1, 5, 4, 3, 2, 6 ke? Kita nak kena kenapa penting firing order? Sebab kita nak kita kena bahagi berapa? So kita tahu kita punya reference planes adalah 720. Okay, first adalah nak tentukan firing order dia. We need to nanti boleh tahu. Okay. First adalah kita kena dapatkan dia punya theta lah. So theta sama dengan 6 cylinder 4 stroke. So maksudnya 4 stroke 720 bahagi 6 kan. So setiap silinder tu theta dia adalah 120 degree. So bila kita lukis, kedudukan dia must be kedudukan must be macam mana? Kedudukan dia bila kita lukis, kedudukan dia mesti jadi macam ni. So nak tentukan firing order dia macam mana? Setiap ni 120 degree. So biasanya kita akan start dengan 1 lah. 1. Contoh kita nak buat ataupun kita nak tentukan 0 daripada atas lah. Kita start dari 1. And next, lepas 1, macam mana kita nak tentukan? Adakah kita nak pergi ke 2 ataupun 3? Okay, macam mana kita nak tentukan? First adalah kita tengok kita punya reference kat tengah kan. Dekat tengah. So 1, 2, 3, 4, 5, 6. 6. Okay. So, bila kita taking from reference, nombor 1 dia akan start dengan nilai negatif ke kiri, positif ke kanan. So, 1 adalah negatif, should be apa? Negatif apa? Negatif 2.5D, betul? 2.5D. Number 2 is negative 1.5D. Number 3, negative 0.5D. Number 4, 0.5D. Number 5, 1.5D. And number 6 is 2.5D. So, nak tentukan firing order, kita kena start dengan macam mana nak tentukan ni? Sekejap. Should be 1. 1, kita start dengan 1, and then lepas 1 kita boleh 1, 2, 3, 6, 5, 4. Kod. Okay, so 1 lepas 1 kita boleh pergi 2 kan? Betul? 1, 2, 3. Lepas 3, 6, 5, 4. Betul? Okey. Siapa beritahu jawapan dia? 1, 2, 3 dan 5, 4. Syami, cuba explain. Macam mana dapat 1, 2, 3 dan 5, 4 ni? Kawan-kawan nak tahu juga? Cuba beritahu. 1, 2, 3, 6, 5, 4. Bagi dia punya D to balance. Okey. Betul. Yes, betul. So, bila 1 ke atas, 1 adalah negatif 2.5. So, nak balancekan dia punya silinder, dia must be positif 2.5. 1 must be dengan 6. Betul? Okay, next kita letak 2 dekat sini. For example, let's say we put 2 is here. Kita tahu 2 adalah negatif 1.5. Jadi, untuk balancekan dia, we should put berapa? 5. Dekat sini kan? So, 2 dengan 5. And last one, kita ada 3. 3, nak balancekan dia, kita kena letak 4. Jadi, kita punya firing order mesti 1. Lepas 1 must be 2 lah. Mesti 2. Lepas 2 mesti 3. Lepas 3 mesti 6. Lepas 6 mesti 5. And lepas 5 must be 4. Jadi, kita punya firing order adalah 1, 2, 3, 6, 5, 4. Okay, clear? Clockwise, yes. Dia must be clockwise. Dekat sini, kedudukan dia. Okay. 1, 2, 3, 6, 5, 4. Mesti clockwise. Okay, so dah dapat firing order, dan kita boleh teruskanlah untuk dapatkan dia punya balancing plane. Okay. Sama juga, first kita buat table lah, senang. Kita put our table. Semua plane yang ada. So, plane M, R, D, MRD, theta dengan 2, theta. So, this is our plane. So, start dengan firing order lah. 3, 4, 5 dengan 6. Okay. So, 1, 2, 3, 6, 5, 4. Okay. So, MR, D, MRD, theta to theta. Okay, so number 1. So, biasalah dia tak bagi dalam bentuk nilai kan. So, just parameter, just put SMR lah. Same SMR, MR. D kita boleh letak dalam bentuk negative 2.5. Negative 2.5. Negative, sorry, positive. 2 adalah positif. number 2 negative kan, negative 1.5, and then we have number 3, we have negative 0.5, 0.5, number 6, 1, 2, 3, 6 adalah 2.5, so 2.5. Number 5 is 1.5, and last one we have number 4, 0.5. Okay, so this one D lah, D. So MRD must be negative 2.5 MRD. This one negative 1.5 MRD, negative 0.5 MRD, 2.5 MRD, 1.5 MRD, and last one 0.5 MRD. Okay, and then theta. What is our theta? Theta we start with 0 lah. 0, and then number 2 should be 1, 2, 0. Lepas tu dia pergi number 3 must be 2, 4, 0. And then dia akan pergi ke number 6 balik, 3, 6, 0. And then pergi lagi 4, 8, 0. And last one kita ada 600 kan? 600. And then 2 theta darab je lah. 0, 2, 4, 0, 4, 8, 0. And then we have 7, 2, 0, 9, 6, 0, and last one 1, 2, 0, 0. So there is our 2 theta. Okay, done. Next adalah kita tentukan dia punya primary force. So how to find primary force? So dia ada bagi reference tak dia punya angle kedudukan? Tak ada kan? So tak ada, maksudnya kita consider macam ni lah. So number 1 should be upward lah kan? So number 1, number 6 dekat sini adalah number 2 and number 5, and dekat sini adalah number 3 and number 4. So yang ni dah balance kan? So there is no unbalanced primary force, so balance. Okay, put dia punya omega dekat situ. Okay, and then untuk secondary force pula, secondary number 1 and number 2, secondary force. So how to find secondary force punya position? Number 1, of course lah dekat atas lah, number 1, and then number 2. How to find number 2? Should be 2 theta, isn't it? Secondary force should be 2 theta. So theta kita adalah 2 theta adalah number 2 tu 240. 240 kat mana? Kat sini kan? Should be here. Okay, and then number 3 480. 480 kat mana? 480 must be dekat sini, betul? Number 3, and then number 6 dekat sini, number 5 dekat sini, and last one number 4 dekat sini. Okay, betul? 1, 6, 2, 5 and 3, 4. 1, 2, 3, 6, 4, 1, 2, 3, 6, 5, 4. Alright, 1, 2, 3, 6, 5, 4. So yang ni balance ke tak? For secondary force already balance kan? So balance. Okay, next adalah primary couple. Oh, sepatutnya nombor 2 kita buat primary couple tu, tapi tak apalah, sama je. So number 3 kita buat primary couple. Okay, untuk primary couple ni kita kena tengok dia punya ni lah, nilai MRD ni. MRD negative 2.5 MRD dekat mana? Okay, number 1 is upward, so kat atas lah. So FM primary couple number 1, MP 1 should be negative 2.5 MRD. So negative 2.5 MRD. Okay, and number 6 pun sama. Number 6 mana? Number 6 2.5 MRD. MP6 adalah 2.5 MRD. Okay, and then dekat sini refer kepada nombor 2. Nombor 2 adalah negatif 1.5 dengan nombor 5 kan? Sama. So MP2 negatif 1.5 MRD. MP5 pun 1.5 MRD. And this one adalah 34. 34 adalah MP3. MP3 berapa? 3 negatif 0.5 MRD. Negatif 0.5 MRD. MP4 0.5 MRD. Sebenarnya omega square ni, omega square, kena buat omega square baru dia complete dia punya formula untuk couple. So kat sini balance ke tak for primary couple? Balance lah kan? So bila kita look at the summation of each cylinder, dia mesti 0. Negative 2.5 plus 2.5 0. Negative 1.5 plus 1.5 also 0. Negative 0.5 plus 0.5 is 0. So primary couple is balanced. Okay, balance. And last one, number 4 is secondary couple. So secondary couple kat mana kedudukan dia? Should be 2 theta. So 2 theta dia refer dekat sini lah, tengok sini 163425. 16. So 16 sama. Betul? Sama juga. So 16 negatif 2.5 MRD. M secondary 1. M secondary 2 pun 2.5 MRD omega square. And this one is number 3. Number 3 dia terbalik ni je. So MS3 is negatif 0.5 MRD omega square, and MS4 is 0.5 MRD omega square, and this is MS2 negative 1.5 MRD omega square. MS5 is 1.5 MRD omega square. So yang ni pun balance kan? So tak ada nilai yang tak balance. All the force and couple are balanced. Alright? Firing order 1, 2, 3, 6, 5, 4 would balance the engine due to number 1 is balanced by number 6. Okay. Number 2 is balanced by number 5. And number 3 is balanced by number 4. Okay. Is that clear? Birah, ada soalan nak tanya? Any question so far? Tak ada? Semua faham? Tengok dekat apa tu? Dekat last apa? Last slide. Yang mana ni? Last tadi. Yang ni ke? This one. Kenapa? Ada, saya ada rekod, nanti saya masukkan dalam e-learning. Okay. Okay, so if no question, then we done our topic for balancing topic. Okay, kita ada dua jenis. We have bukan jenis tiga. We have three types of reciprocating balancing. We have inline balance, we have radial balance, dan juga kita ada V engine balance. Tak sempat nak buat V engine, tapi tak apalah. Refer dekat video. Saya dah tunjuk satu contoh yang V engine punya. Okay. Yang V engine dia melibatkan left hand side dan right hand side. Okay. So, ada lagi soalan nak tanya? Any other question? Tak ada. So, if no question, then I think that's all for our topic, and next week's mid-semester break, isn't it? Betul? Next week is mid-semester break, so we have no class on next week's. And then we continue our class next 2 weeks with new topic, which is flywheel. Alright, we have a last topic for first part of our course, which is flywheel, and then for second part is vibration. Okay, that once we're done for flywheel topic, then we can proceed with vibrations topic, right? Which is I think quite interesting for vibration topic. Okay, so we have another topic to be completed for first part of machines. Okay, and then before we stop, then your marks for test 2 is ongoing, tak siap lagi, so I will give you your result for test 1 marks before Thursday next week, because Thursday adalah last day untuk withdraw subject kan. So kalau rasa macam nak draw balik ke subjek ni, okay, boleh fikir-fikirlah once you get your result nanti. Alright, but it's okay. Alright, kalau still kalau macam still tak boleh nak teruskan dengan subjek ni, it's up to you. Okay, kalau rasa boleh, and then boleh sambung, boleh continue, but my suggestion is you still have a time to improve your marks, because saya tengok soalan 1 saya baru habis marking soalan 2, baru habis marking soalan 1, dan average yang saya boleh katakan dalam 8 lebih lah, 8/15, lebih kurang separuh jugalah average dia tu. Okay, but it's okay, tak apa. So before we leaving, one more thing, I have uploaded your assignment 2, okay, in the e-learning, so please make sure that you complete assignment 2 before Saturday next week. Okay, and topic is about balancing. Alright, so any other question before we dismiss? No? So if no question, then ada soalan? Sorry, I can't hear you, Remy. Okay, if you can revise back the topic about balancing. So we have 2 videos for lectures, and I will upload these recorded videos in the e-learning that you can check balik. You can revise balik all the questions and exercise yang kita buat, sebab dalam test pun soalan lebih kurang macam ni je, right? Cuma mungkin ada sikit-sikit beza. So the most important thing is you must know how to find the forces and couple, and what kind of forces or couple that you need to find it. Okay, and one more thing is you must know how to identify firing order. Okay, because some question dia tak bagi firing order. You need to identify you punya firing order macam mana. Okay, so I think that's all for our topic. Then see you on next 2 weeks. So happy holiday for next week. Seminggu kita break, and then kita jumpa lagi lah untuk next week for a new topic. So thank you very much. You can dismiss now. Assalamualaikum.